Okay, I'm going to take this derivative, and in fact I'll make another video because this is probably not the way I would do it, but it doesn't matter, this way works. Maybe it's more steps this way, but I know most of you right away think of the quotient rule, so let's use the quotient rule. The only thing I'm going to be aware of along the way is I'm going to have to end up distributing things, so I'm going to write everything as exponents, meaning if you remember, the square root of x can be written as x to the 1/2 power. So I'm just going to do that because I know I'm going to end up distributing everything. So I leave the bottom alone times the derivative of the top minus the derivative of the bottom. So side note again, is 1 over 2 square roots of x, which is the same thing as 1 over 2x to the 1/2 power, which is the same thing as 1/2 x to the minus 1/2. And again, I'm just doing this because I know I'm going to have to end up doing some distributing. So x to the minus 1/2, and then I leave the top alone, all over the bottom squared. So far so good. Now I'm going to start doing my distributing. So that's going to take you back to remembering when you multiply with same bases, you add the exponents. So x to the 1/2 times 2x is going to be 2x to the 3/2, because that's 2x to the 2 over 2, right? And then plus 8x to the 1/2. Now I'm going to distribute this. So I'm going to get minus 1/2 x to the 3/2, because 2 could be 4 over 2, 4 over 2 minus 1/2. Minus, well, let's go ahead and take a half of 8, which is 4, x to the 1/2, because that'll be 2 over 2, and 2 over 2 minus 1/2 is 1/2. And then finally minus 3 over 2 x to the negative 1/2 power, all over x. Okay, so this does get pretty messy with exponents, and that's why I said I don't know that the other way is easier, but I probably would have tried the other way. So from here, I'm going to see if I can combine anything like those and those. So if I can combine 2, or 4 over 2 minus 1/2 would be 3/2 x to the 3/2 power. I combine the 1/2 powers, so 8x to the 1/2 minus 4x to the 1/2 is going to be plus 4x to the 1/2. And then the lowly term that's all by itself, the last term. So from here, what I'm going to do, because all of this is over x, instead of drawing the big long line, I'm just going to individually put each one of these fractions over x, because then I'm going to do some reducing, because remember, when the bases are the same, you subtract the exponents. So let's do that in kind of a couple of steps to make sure everybody's okay with that. I'm going to do 3x to the 3/2 power over 2x. In fact, I don't even think I'm going to do that. I'm going to do a common denominator here. I'll do it with this piece here. So this piece is going to end up being 4 over x to the 1/2. Because remember what you're doing 1/2 minus 2 over 2, which is x to the negative 1/2, and then you bring the 1/2 down to the bottom, minus 3 over 2x to the 3/2, because I'm taking negative 1/2 minus 2 over 2, which is negative 3/2, and I bring it to the bottom. So from here, I see that this is the biggest denominator, so that's my least common denominator. So I just go through and I see what everything needs. It's kind of how I do fractions. So I have 3x to the 3/2 all over 2x. I already have a 2. I have 1x, but I need 3.5. So I need to add another half, right? Because that's 2 over 2. And so I do the same thing there. This piece here, I already have 1/2, but I don't have a 2. And then I need 2 over 2 to be able to add those to get the 3/2. So do the same thing up on the top. And then minus my favorite piece, because it has the least common denominator. I don't have to do anything. So now that all of these have the same denominator, I will just write this as one fraction. And then I just look at the top and say, well, that'll be 3x to the 4 over 2, which will be 3x squared, plus 4 times 2 is 8. 2 over 2, of course, is 1, so that'll be 8x minus 3, and that's the final answer.